Those who are early risers will be witness to a rare planetary alignment of Mercury, Saturn, and Jupiter just before sunrise. Especially rare and quite spectacular was the placement of the waning crescent moon yesterday, March 10th. As some of you may be aware, the vernal equinox, the astronomical beginning of spring, occurs this year on March 20th. This is the point where there are 12 equal hours of daylight and darkness, and we're going to cover that in a separate video. Welcome friends, this is Dr. Jim Daly, your host, bringing you this edition of The Sky Tonight for the week of March 12th. We open looking due south and note the major constellations of winter, Canis Major and Orion, are well placed just west of the meridian at 7:30 p.m. Eastern Standard Time. In previous videos, we covered these constellations and the special objects of interest in each. Please see the suggested video at the end of this video for the link. Starting from Tuesday's date, March 9th, we're going to run time forward and stop at 5:30 a.m. Eastern Standard Time just before sunrise and take a look at the spectacular view. We see here the stars of spring rising. Pause it here for a moment. Point them out. We have Virgo with Spica. Take a moment here to look at this. Check this out. Okay, that's Virgo. Right there, the bright star Spica. Continuing. Those are the constellations of spring. They'll be upon, this is actually at just shy of 11 p.m. So we stay up a little bit later, we can start to see the constellations of spring beginning to rise in the east, southeast. So continuing our march forward in time. It's now coming up on 1:30. We pause it here again. You start to see the Milky Way rising. The constellations of spring and summer will be with us very soon. Here's the summer triangle, Vega, Deneb, and Altair, and we just see hints of the Milky Way starting to show. This is looking south, southeast. This is the galactic center, the Milky Way's galactic center, our galaxy's heart, as it were, its nucleus. It's right there. Here's the bright red supergiant star, Antares, the heart of the Scorpion, the Scorpio. Okay, these are all stars and constellations of summer that will be with us in a few short months, in a few short weeks actually. Within 6 weeks or so, these constellations and stars will be well placed for viewing. Okay, continuing forward in time. We're going to see there's Delphinus, the dolphin right here. Okay, you see the summer triangle is becoming well placed, and this is 4 a.m. in the morning, just after 4:15 in the morning. So those of you who are early risers get to witness this, the serenity and the peace and tranquility of the early morning hours just before sunrise. You can see the placement of the Milky Way. Quite prominent now. Okay. Continuing. And here we go. Here's the spectacular view. This is 5:30 a.m. Eastern Standard Time. You can see the moon just above the waning crescent moon, just above the horizon here. We'll zoom in on it. Okay. This is one day before new moon. New moon is the point in the lunar cycle where the alignment between the Earth, the moon, and the sun is perfect. The moon is in perfect alignment with our view towards the sun, and this is the only phase of the moon where we can witness a total eclipse. And not every month produces a total eclipse because the moon doesn't orbit. The moon's orbit is 5 degrees from the plane of the ecliptic, so we don't get to see a solar eclipse every month. Okay? And we see Jupiter, we see Mercury, Jupiter, and Saturn. We'll zoom in on each one of them. Take a look. Zooming in on Mercury. Mercury is at about the 60% phase. A little bit more than half of its surface is illuminated by the sun. Zoom back out. Take a look at Jupiter. Okay, and what's the nice thing about Stellarium is that we can actually see the positions of the satellites of Jupiter, the four Galilean satellites, made famous 400 years ago by Galileo when he first saw them in his telescope. The four Galilean moons, Io, Callisto, Ganymede, and Europa. Io is the closest, moves the fastest, and is seen right here. This is Io. Okay, we can zoom in on Io. Okay, it's a volcanic, one of the most active moons in volcanism in the solar system. Hot lava is spewing forth from from within Io due to the tremendous tidal interaction between Jupiter and the moon itself. This is causing tremendous stress, causing the tectonic forces and the internal dynamics of the moon to produce many lava flows and volcanoes. Okay, there's a tremendous gravity from Jupiter. And I should mention while we're here, we're gearing up for a mission to Europa in the coming few years called the Europa Clipper. And that will be arriving, well, the launch date is scheduled for 2025 or 2026, depending on what NASA finally decides, what launch vehicle, what booster NASA finally decides on using to send Europa Clipper on its way to Europa. Whether it's going to be the SLS, which is the Space Launch Systems, NASA's new little booster, currently under construction and program development, or commercial endeavors like SpaceX. So that remains to be seen. But it's scheduled to arrive at Europa somewhere before 2030, within the next 9 years. Okay, so let's zoom back out from Io. Okay, just as a quick segue. Okay, and this is how Jupiter would look in a decent amateur telescope. The bands of Jupiter, the detail on the cloud tops, this is realistic. I can say that because I've witnessed it like this most of my life, looking at Jupiter through telescopes. Okay, let's zoom back out. We can zoom in on Saturn. And again, as was the case with Jupiter, Saturn's family of satellites, these are the positions of all of Saturn's satellites in real time. As we would see it, this is a very good view. This would be a very good view in an amateur telescope. This is what Saturn would look like in a good amateur telescope with the moons visible. You can see the moon Titan here, Saturn's largest moon, and a moon very similar in many ways. It's thought to what the Earth was like in its infancy. Let's zoom in on Titan. Take a look. We're not going to see much because it's permanently shrouded in a very thick atmosphere of nitrogen. So visually see the surface, it's almost impossible. In fact, when the Cassini mission, now decommissioned and lost into Saturn, spectacularly in September of 2017, the Cassini mission was deliberately orbited into Saturn, lest it would possibly contaminate any impact contaminate the surface of any satellite if it were to impact it in a later date. And the mission planners and controllers at NASA and JPL thought it was the best use of the remaining small amount of propellant left on the vehicle as a controlled deorbit into Saturn. And that's what we did. So in any case, anytime Cassini came close to Titan, we could see the upper atmospheric haze of Titan, but it was almost impossible to visually see the surface unless Cassini turned on radar and infrared. We could actually see surface very surface details with high resolution using Cassini's onboard radar. So, okay, so zooming out from Titan and Saturn and all the other amazing moons of Saturn. Should mention also while we're here, Enceladus, the moon Enceladus is the, we mentioned earlier when we were talking about Jupiter, volcanism on Io. Well, Enceladus is known, famous for its cryovolcanism, or the eruption of ice volcanoes on its surface. Frozen water, it's believed, is beneath the crust of Enceladus, and through tidal interactions with Saturn, just like on Io and Jupiter, the liquid water emerges from underneath the crust and freezes instantly as it ascends into the very thin, tenuous atmosphere above Enceladus. Okay, and rains back down as snow, covering it, and this is what we see. It's a brilliant reflector. Even though it's very small, it's quite visible even through an amateur telescope. You can see it because of its albedo, or its reflectivity. Okay, that's Saturn. We zoom back out. We'll go back to our early morning sunrise view. So those of you who are early risers have to rise early for your jobs or whatever reasons you have to get up early. This is the view you would have seen yesterday, March 10th at 5:30 in the morning, Eastern Standard Time. Okay, I hope everybody enjoyed this video. Please do like, subscribe, and share, and leave your comments in the link in the description and comments section below. Thank you. This is Dr. Jim Daly of Astronomy for Change. May you come to love the stars too fondly to be fearful of the night. And remember, the Earth is a mote of dust floating in a sunbeam. That's reality. Everything else is just marketing. The great philosopher Plato famously said, "Astronomy compels the soul to look upward and leads us from this world to another." Astronomy for Change is a non-profit organization whose mission is to effect positive change through astronomy and science education. It is our belief that by inspiring and empowering current and future generations to become interested and engaged in astronomy and science, this positive change will be realized. If you found this video helpful and educational, please like, subscribe, and share. Also, why not consider supporting us on Patreon? Head over to our homepage, astronomyforchange.org, click Support Us via PayPal or Patreon, and choose a membership level suitable for you. Every little bit helps us produce the great content and further our mission. Also, why not consider becoming a member? Choose the membership link here, click it, put your name and your first name and your email, and you'll be added to our list. You'll receive a comprehensive digest of all our videos and articles and all our great content. Joining and becoming a patron helps us grow and improve and more fully realize our mission. Thank you. This is Dr. Jim Daly for Astronomy for Change. Until the next video, please stay well and keep looking up.